Namaste, ma'am. I am Akila Ganeshan. I have been working in DAV for 25 years. So I am here just to share my experiences with you. Okay, that's the main thing. So to start the class, I would like to start with a story because everybody likes, irrespective of the age, we all like to hear a story. This is a story about a very, very successful teacher who had created many big shots like say CEO, judges, and they had invited the teacher for a party. And the story goes like this. I like this story very much. So I thought I'll start this session with this story. So the CEO, it was a dinner party and the guests were sitting around the table discussing life. One man, a CEO, decided to explain the problem with education. He argued, what's a kid going to learn from someone who decided his best option in life was to become only a teacher? To stress this point, he said to another guest, "You are a teacher, Mrs. Singh. Be honest, what do you make?" Right? Now, immediately the teacher is replying, "You want to know what I make? Well, I make kids work harder than they ever thought they could. I make kids sit through 1 hour of class time when their parents can't make them sit for 5 minutes without iPod, GameCube, or movie rental." This is very, very true, is it not? We are making them sit for 40 minutes in the class without even thinking about all these gadgets. Yes or no? So that is the thing she told. I make kids wonder. I make them question. I make them apologize and mean it. I make them have respect and take responsibility for their action. I teach them how to write and then I make them write. Keyboard isn't everything. I make them read. I make them show all their work in maths. They use their God-given brain and not man-made calculator. This is also very, very true. It's not math. We are all making them to work. We are all making them use their brain. Is it not? Right? I make my classroom a place where all my students feel safe. That's very, very important. We are making them feel safe. Right? And finally, I make them understand that if they use the gifts they were given, working hard and follow their hearts, they can be successful in life. So this is what is the reply given by the teacher. I hope that every teacher should feel proud about being a teacher, because as teacher, we make all this. We make responsible citizen also. So when I'm talking about the positive side of a teacher, I also should say that a coin has two sides. Yes or no? Right? So I should also say the negative side of it. Many of us very commonly hear this dialogue. A person saying, "I would have become a doctor if I had not got a good biology teacher. My biology teacher did not explain properly." So it becomes the responsibility of each and every teacher to reach the minds of the student in order to make them like the subject. So the general saying is that if a child likes the subject, he or she will automatically start learning. So it is our responsibility to make things very interesting. So in earlier days, no, whenever somebody says, we totally believe it. Is it not? Yes. For example, my mother used to say that early morning, we have to clean our outdoor road and put a column, right? Column with arisi maavu. I never asked her why. But nowadays, children are not like that. They want to know why, what, how. So it becomes our responsibility to tell them why they should learn chemistry. So the first slide I'm going to share with you is that. Okay. Am I audible?
Yes, ma'am.
Yes. So today we are going to see how to learn chemistry in an interesting way. So we are going to see that. So let me share the next slide. Learning chemistry in an interesting way. So for this, first we should make the child understand why and how should we learn chemistry. Why should we learn chemistry? Because all the children we are handling are in the class of 9th and 10th. They will never do anything if they don't find things convincing. If you are not able to convince them, no matter how well you teach, they are not going to learn. So it is our responsibility to make them convince why and how we should learn chemistry. So now here you can see that we are learning chemistry because it's often referred to as central science because it joins together physics, maths, biology, medicine, earth, and environmental science. What do I mean by that? Because chemistry is helping us to understand the world. It tells us why the leaves change the color. Do you know that whenever the leaf is falling down, the color of the leaf changes? What is the reason for the leaf to change its color? The leaf changes its color because of the presence of an acid called abscisic acid. ABSCISIC, abscisic acid. It is the abscisic acid. Can you see the board, ma?
Yes, ma'am.
Abscisic acid. ABSCSIC. Abscisic acid. So the abscisic acid is only responsible for, the change of the leaf, and the leaf changes its color and falls down. So this is abscisic acid. Where will you learn? You are learning in chemistry. So the chemistry is becoming a central core and it is relating us to biology. Next, we also learn how cheese is made, how soaps are used for cleaning. And we recently learned, had an article about Maggie. Children are fond of eating Maggie, is it not? Maggie is the most favorite food for them. But in the year 2015, you know that Maggie was banned. Do you know why? Anybody? Okay, I'll tell you. Maggie was banned because it was found to contain monosodium glucomate. Monosodium glucomate, MSG. This MSG is one which is responsible for giving flavor to the food. Food is getting flavor. Why children are liking it, Maggie, Abdina? Because of the presence of MSG. But this MSG should be added in the food in a proper quantity. But in Maggie, it was found to be added more. So chemistry gives us a knowledge about the products, what we are having. So when they learn chemistry, they can find out which is the preservative used. Okay, which is the material, whether the material what is used is good for them. For example, we know that vinegar is added in pickles as a preservative. Is it not? Yes. Yeast is added in cakes. Is it not? So we know only when we learn chemistry, we will know about all these things. So that is why chemistry is referred as the central science, because it is joining physics, maths, biology, medicine. Medicine, whenever you are eating any food, which heavy food, you see that acidity develops in the stomach. Is it not? We are having an antacid. So the antacid contains magnesium hydroxide. Yes or no? So the magnesium hydroxide is helping us to neutralize the acid, hydrochloric acid that is present in the stomach. So only when I learn chemistry, I will be able to understand what is happening in me, what is happening around me. So this is the first thing you have to give. So whenever I go to my class, first day, I never talk about anything. I will tell them why they should learn chemistry. Once the child understands why he should learn chemistry, he will automatically start learning. So the first thing, so Cooking, any of us like cooking, is it not? We like to make tasty pastries. We like to. So when you make a cake, we are adding baking soda in it. Okay, baking soda is what? Sodium hydrogen carbonate and tartaric acid. Okay, baking soda is not sodium hydrogen carbonate alone. It is a mixture of sodium hydrogen carbonate and tartaric acid. Why tartaric acid is there? Because when you are making the cake, the sodium hydrogen carbonate releases carbon dioxide. Okay, the sodium carbonate and tartaric acid react and they neutralize so that the cake is not tasting bitter. So why baking soda is added? Baking soda is added for making it fluffy. Why tartaric acid is present? Tartaric acid is helping us to avoid the taste of the cake to be bitter, because you know that it's an alkaline salt and alkaline will give you a bitter taste. So in order to avoid, we are using tartaric acid. So this is the knowledge. How will I get the knowledge? I'll get this knowledge only when I learn chemistry. So it becomes very, very essential that we have to learn about chemistry. Now we have made the child to understand the reason why he should learn chemistry. Next, you can also tell him what are the exciting careers that are there. Suppose I learn chemistry. What is it I can become? I can become a forensic expert. Boys love to do this, is it not? Yes. So whenever there is a murder, immediately all the movies they show, is it not, how they spray a chemical, how they find the handprints and all those things. And boys would love to take this field, is it not? So they can become a forensic expert. They can become a chemical engineer. They can become toxicologist. They can become waste management professional, because you know that there are many waste is generated in so many places. How to make use of them in a proper way. Recently, one person has developed bricks using waste. Is it not? He has collected all the waste, plastic, this thing, and made bricks. He says that you can use this rather than the brick because it will have more sturdity. So waste management professionals are able to, remove the waste and make them, convert them into useful products. Quality control chemist, every industry, every food industry need them, is it not? Yes. Biochemist, pharmacologist, everywhere you see that whenever you need to prepare a medicine, you need it. Food safety professional. So these are the exciting careers that are available for those who want to take chemistry as their profession, chemistry as their subject. So this is what you should tell them. So we are not learning a subject just like that. Simply it's given, we are not learning. We are learning a subject because it's going to be the central part of our life, because it has this many options to explore. So this is what you should first make them understand. Any questions, ma'am? Shall I proceed?
Yes, ma'am.
Okay, thank you. So the next slide we will move on. So now chemistry, you see that when you say chemistry, people are scared. Yes or no? They are very scared. So now it becomes the responsibility of the chemistry teacher to make the child understand chemistry in a fun way. So now I'm going to tell you a technology wherein you can use fun way of learning chemistry. First one is illustrate with analogy. What is it? Suppose I want to illustrate electronegative character. What is electronegative? If an element gains electron, then you call that as electronegativity. Okay, so when I say electrons are gained, the child is not going to understand that. Here you can see that this is the boy who's there. He is the element, right? And he is carrying, is pulling the electron towards it. Can you see there are two red balls and the two red balls are being pulled. So you draw this picture and you say that if an element pulls the electron towards it, then it becomes electronegative. Now he will be able to understand it very, very quickly. So as far as possible, try to draw diagrams, simple diagrams to explain what you want to say. Have I made myself clear? Yes. Shall I give you another example? Okay, I'll give you another example. Okay, can you see my board? Can you see my board?
Yes, ma'am.
Okay. So now you can draw two pictures like this, right? Simple one. I'm not very good in diagrams. Okay. Biology teachers will be very, very good in diagram, but I'm not very good in diagram. Okay. Here one more like this. Now you look at this picture. Okay. Here you can say that I'm going to explain what is reducing agent. Okay. A reducing agent is one which is giving electrons, which is donating electrons. Now, here you can see this picture. I will say that this is reducing agent. You can see if you closely note in this picture, what do you see? Both are both same? Both are same? Can you see the picture? Yes, ma'am. Both the diagrams look the same.
No, ma'am. Yes, ma'am.
What is the
There's
difference?
a difference in height, ma'am. I see.
No.
Okay.
I'm talking about the picture. Here you can see that the
Symbol. Okay.
diagram here it's smiling. Here it's not smiling. Okay. So I will say that this boy is smiling because he is having excess of electron. Okay. What is the job of a reducing agent? A reducing agent will be willing to donate an electron. Is it not? So this is a reducing agent and it is willing to donate an electron. Why are using donate? When I give it willingly, it's called donation. Okay, when I cry and give, it is not called donation. So that's why I put a smiley. Right? Now, this fellow, what is he? He is the one who is going to accept the electron. He is sad. Why he is sad? Because he is not having enough electron. If somebody gives the electron, he will be very happy. So you can show that. Right? So now so here what will you say? Reducing agent is donating electron, that is loss of electron is taking place. Okay, the one who is accepting the electron, what is he called as? You can call him as oxidizing agent. Oxidizing agent. Okay, so you see that what does the oxidizing agent do? He gains electron. So when you explain this with the picture, the children will be able to understand it better. So a reducing agent will always give electron. So loss of electron. Oxidizing agent will always gain electron. So you see that it's called the oxidizing agent. What is the example you can give? Fe plus, okay, 1 minute. Fe plus S gives FeS. Now here what's happening? You are going to identify the reducing agent and oxidizing agent. Fe plus S gives FeS. Now here you see that Fe is losing electron. So here Fe is losing electron. Fe is forming Fe plus plus. Okay, right? So you see that Fe is losing electron. Therefore, Fe will be what agent? What agent, ma'am? What agent it will be?
Reducing agent, ma'am.
Reducing agent. Very good. So you see that Fe will be the reducing agent. Which will be oxidizing agent?
Sulfate, ma'am.
Sulfur will be the oxidizing agent. So the one which loses electron, we call it as reducing agent. The one which gains electron is called oxidizing agent. You can draw pictures like this and you can explain them in a simple manner. Okay, in a simple manner, and make them understand. So this will reach the children in a better way. So use, okay, you can draw cartoons, or you needn't be very good in drawing, but you can use some kind of pictures to explain. So the first fun way of learning is illustrating with analogy. Any doubts, ma'am, in this? The next fun way of learning is correlating with everyday life. You have to correlate whatever you teach with everyday life, connect with them so that they are able to understand what you are teaching. For example, when I'm teaching corrosion, we have learned about corrosion. What is corrosion? Corrosion is formed on a surface of an active metal. Yes or no? When will it be formed? When it is attacked by air, when it is attacked by water and other substances. So you see that here, corrosion, for corrosion, you need what all you need? You need air, you need water. So it's an oxidation reaction. So corrosion is one of the application of oxidation reaction. So when you're teaching this, you can give example as why is the Statue of Liberty? Everybody will know about Statue of Liberty. Yes or no? So here on the screen, you can see that why Statue of Liberty is blue in color. Now, when you talk about Statue of Liberty, you can connect some amount of history. This is what we call it as correlating with life. Simply, you're going to only teach chemistry. Children are not going to like it at all. You have to teach them with examples. You have to connect with history, with current affairs, with everything possible. So when I'm going to show them the Statue of Liberty, I will be telling them that this Statue of Liberty was installed in the year 1886 and it is made up of thin copper. And when it was established, you know what was the color? The color was brown. But as the metal was exposed to moisture content, and you see that now what is the color? It's almost, what is the color? What's the color, ma'am? What is the color you can see? It's almost greenish blue. What is the reason for it? You should know that the blue color or the bluish green color is because of the chemical reaction between copper and the moisture and oxygen that is present in the atmosphere. This process, they call it as patination. Pattition. So patination. So you can say that the green color is because the bluish green color is due to the formation of copper oxide, copper carbonate, and copper sulfate. It is all these three things which are formed that is responsible for the blue color of the Statue of Liberty. And the Statue of Liberty is talking about the freedom. It is welcoming all the immigrants who are there coming from the sea to America. So this is the concept why the statue has been installed in this place. So you can show the example of Statue of Liberty and you can talk about it. You can also give some amount of history that it was established in the year 1886 and it was donated by a France people to the people of United Kingdom, okay, as an icon of freedom, okay, and it is welcoming all the immigrants who are arriving through sea. So this information you can give. Like that, when you're talking about corrosion, if you're going to correlate it with the day-to-day affair, if you're going to show them some live objects, live things that is happening around us, they will be more excited and thrilled. Okay, when you are talking about US, of course, we have to talk about our India. Yes or no, madam? Yes or no? Because we are living in India. What can you see in the next picture? Can anybody say? What is it you see? Yes. What is this picture shows?
Ashoka Pillar.
Iron pillar.
It's an iron
Iron-
pillar.
iron.
Yes, it's an iron pillar which is in Delhi. Right now, if you talk about this pillar, it is 7.2 meter tall. Okay, 7.21 meter tall. And you should know that this pillar, why it is famous? Can anybody say? Why is it famous? Simply, we are not going to talk about it now.
It does not rust, ma'am.
Correct. Very good. Super. Yeah. Super. So it doesn't rust. So when you tell this, the children will be very much surprised because all along, whatever they see is they've seen that iron gets rusted. It is made of iron and it is not rusted. So we should be, they would like to know, this is how you have to create and instill the curiosity in the minds of children. Okay. So you will say that it is not rusted. Do you know why? Because the composition with which it is made is such. It is made up of wrought iron. Nearly 90% of the pillar is made up of wrought iron along with phosphorus content and low sulfur content. High phosphorus content is there, low sulfur content is there, little amount of magnesium is there. Here you are mixing many elements. So when you mix many elements in a fixed proportion, what is it called? What is it called, ma'am?
Alloy.
Alloy. Very good. Super. So it's an alloy. So it's an alloy made up of wrought iron. It has high content of phosphor. It has a very low content of sulfur. And it has some amount of magnesium. And the reason why, in spite of being, it is there standing for nearly 1,600 years, this you have to give a stress. Because when you give the stress on this, they will understand the importance of architecture in India. Okay, how India is culturally rich. Okay, what beautiful monuments we are having. What beautiful technologies our ancient people have been using. It is our responsibility to create. That's why I started the class that it is our responsibility to create a CEO, to create a director, to create a consultant, is it not? To create an IAS, IPS officer. So whenever he is learning something, he has to understand why and what and how. So it's been standing there for 1,600 years, but still it is not getting rusted. The reason is because of the high phosphorus content. The phosphorus content is making the iron pillar resistant free. Okay, it is not getting rusted. So that is why it is a rust free metal. So when you're talking about corrosion, you have to certainly show these two and say where one statue, what is installed, where people go and visit. It's not, many people like to go and visit. Whenever they go to US, they visit the Statue of Liberty. They don't come up. But there is one in India which is not rusted, and we can be so proud about it. So you have to instill the patriotism in the minds of the children. Okay. The next important thing is mnemonics. What is a mnemonic? You can see that. A mnemonic is a memory aid used to improve long-term memory and make the process of consolidation easier. What is it? Looking very, very complicated. You should know that many chemical rules, okay, elements order, reactivity series are very, very confusing for us. We are not able to understand it very clearly. Even if we understand, it is very difficult for us to remember the order. Because if you change the order and write, there is no use of it. So the children, where they find it very difficult not to remembering the elements, number one. Number two, to remember in a particular order. That is the most difficult task. Now, as a teacher, it becomes our responsibility to make them understand it in a very, very simple manner. Here only mnemonics is going to come and help us. So you can use mnemonics. Okay, so that many chemistry aspects, rules, names of the elements, sequence of elements, their reactivity can be easily and efficiently memorized with the help of mnemonics. What is the example? Let us take the first example. Happy Harry listens BBC network over Friday news. So let us take up this sentence. Happy Harry listens BBC network over Friday news. Now, what is this sentence telling me? This sentence is telling me about the first 10 elements in the periodic table. Now, you write first, if I am going to take periodic table and I am going to start, I will start with this. And I will try to ask them, what is it? Can you find out? This is the arrangement of first 10 elements. You have to round all the first words. First letter. What is the first letter in, can you tell me?
H-L-I.
H. H is hydrogen. Is it not? The first element in the periodic table is hydrogen. Harry la H, what does it represent then?
Helium.
Helium, ma'am.
Then Li, what is Li?
Lithium.
Lithium. What is the first B of BBC? Beryllium.
Beryllium.
Next B is what? Boron. Okay. Next is
Boron, ma'am.
carbon. Correct. What is
Nitrogen.
N? Nitrogen.
Nitrogen.
Okay. O.
Oxygen.
Oxygen. F.
Fluorine. N.
Fluorine. Ne is neon. So now you see that the child will be able to identify and learn the first 10 elements very, very easily. Don't you think, teachers?
Yes, ma'am.
Yes or no? Yes. So you can give them. So when they come to 9th standard, when they look at you, we will be keep on be telling them, learn the first 10, 20 elements, learn first 10 elements. For the first term, we will say at least 10 elements you should know, like that. So you can give them this. Happy Harry listens BBC network over Friday news. I will tell my children to write this first in the rough column. Okay, and write the name of the first element, 10 elements, anyhow, somewhere related to it, some question will come. So once they know the order, they will be easily able to solve the riddle of any question that is being asked. So the arrangement of elements are hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. So they know now. The next one you see there. Please stop calling me a cute zebra crab. Instead, learning how copper miners save gold pit. Now, this seems to be slightly complicated. This is mainly for understanding the reactivity series in 10th standard. We have a reactivity series. We have to learn the order of reactivity series. Yes or no? P stands here for potassium. P stands here for potassium. So P, first letter is P, so potassium. Okay, yes, sodium. Stop la S on the sodium. So first element of the reactivity series will be potassium. Second element will be sodium. Ca is calcium. M will be magnesium. Okay, A cute zebra la A will be aluminium. C cute la C will be carbon. Okay, then Z will be zinc. Then you have Cr crab la Cr is chromium. Then I instead la I vanda iron. So Fe. Then you see that learning la L vanda lead. So I have written Pb there. How la H vanda hydrogen. Copper already given, so no problem. Cu. Okay. Then we have gold pitla gold. So silver and gold. Save la vanda yes vanda silver and gold vanda. So they will learn this order. So this is how the elements are arranged in the reactivity series. You have potassium, you have sodium, you have calcium, magnesium, aluminum, carbon, zinc, chromium, iron, lead, hydrogen, copper, silver and gold. So now they will be able to learn the order and write the order without any hindrance. Any doubts, ma'am?
No, ma'am.
No, ma'am. It's easy.
Right. Next one, Parana. ABR. Can anybody guess what is ABR? It's related to acid, bases, and salt. I've given you the clue. ABR, BRB. These two are
Acid-base
related to
reaction, ma'am.
acid, bases, and salt.
Acid-base reaction.
Any more guesses? How will you
Blue
identify
litmus.
acid, ma'am?
Blue
Can anybody
litmus
say
to
how
red
will you
litmus.
identify acid?
Blue to red, ma'am. Acid
Correct,
blue
correct.
to red.
So
Base red
ABR
to blue.
means acid turns blue litmus to red. Generally, when the children will make mistake here only, they don't know whether it's blue litmus to red or red litmus to blue or acid or base. So I will tell them what comes after A. If I ask them B, then they will say acid turn blue litmus to red. Okay, when they write acid turn blue litmus to red, automatically they'll know what will base turn. Bases turn red litmus to blue. BRB, bases turn red litmus blue. So these are some short notes which will help them to understand. Okay, the properties of acids and bases. So acids turn blue litmus red, bases turns red litmus blue. Any doubts, ma'am?
No, ma'am.
Okay. You're able to learn something. Can I know how do you find the session?
Fine, ma'am.
Interesting, ma'am.
Okay, thank you. Because if there is anything you want to say, you can just share it, because ultimately the main reason is that the session should be in some way useful to you to reach the children. Why are we doing? All our experienced teacher, all are educated. It is not that. So how my experience is going to help you to make children learn chemistry in a comfortable way. That is what is the ultimate aim of this session, my dear teachers. So if you have anything you can share with me so that I will also learn. So learning is a continuous process. It's not that I know everything. It's not like that. I can learn from you also. Is it not? Every day we are learning something new. Is it not? Yes. So these are some of the mnemonics you can use. Even to learn, when you go to 10th standard, they will ask you about what are the elements present in group 1. Yes or no? We have learned. Yes. So group 1 elements, what are the elements? We will see. 1 minute, I'll just rub the board. So group 1 elements. What are the elements we have in group 1? It is lithium, sodium, potassium, rubidium, cesium, francium. These are the elements. Now, how will the children remember it? I tell them it is little nasty kids. Little nasty kids rub cat's fur. So lithium, sodium, potassium, then rubidium, cesium, and francium. Little nasty kids rub cat's fur. So like this, you can tell them, you can train them to give, you can train them with the help of mnemonics, which will help the students to understand it better. Next, we move on to the next topic, internal assessment. Because we are handling 9 and 10 children, the internal assessment plays a very, 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 very important role. They have to understand it is this place where they can score the full marks. Is it not? So how is the internal assessment according to CBSE? You can see here. For periodic test, 3 marks. This periodic test, 3 marks is not very doubtful. Not every child will be getting it. Because you see, unless they get a centum, they will not get this 3 marks. Is it not? Multiple assessment, subject enrichment, and portfolio. So we are going to talk about subject enrichment and portfolio as our next topic. Okay, the next topic we are going to discuss is subject enrichment, which can be either a practical work, or the government or the CBSE has also introduced art integrated projects. So we are going to discuss about art integrated project. as our next topic. Shall we discuss, ma'am? Yes?
Yes, ma'am.
Okay. One minute. Yeah. Art integration in science. So you see that art integration means combining arts with teaching of different curricular areas. Subjects like science and maths can be made to correlate with arts. Sometimes art can clarify science concept very easily. So the main idea of art integrated project is that the child has to prepare a model, okay, based on using arts. So that is the idea of it, right? Am I right? So here what happens, art becomes a medium of teaching. It is also becoming a tool of teaching and learning process. It will strengthen the concepts more clearly, because a child likes to always paint, draw, stick, do things in a creative manner. So they like to do things in a creative manner, and the creativity will help them to understand things more easily, the concepts more easily. So for class 9 and 10, you see that CBSE will take up this art integrated learning as subject enrichment activity. Now only we saw for subject enrichment activity, there is mark allotted. And you have to tell them how important these marks are, so that the child will take it very seriously and it will try to do something, some kind of art integrated work. So for this, generally what I say, for the art integrated project, I will tell them to use the materials that is available at home. They should not spend a lot of money on this. They must try to use materials that are available at home. So for example, can you see this, my dear teachers? Yes,
ma'am.
yes. Here you see that this is an art integrated project that is done by a 9th standard student. Here he has shown the formation of calcium oxide. So we have a topic where the child has to learn to write the formulas. Yes or no? Using the valency and symbol, they have to write the formula of a compound. So that is there in our topic. So I told them you can show the formation of any one compound, which how it is formed. So for that, the child has used this. Now here you see that the child has taken calcium oxide. Here she has taken the outermost shell of calcium. Calcium atomic number 20. 20 is the atomic number of calcium. Appo electronic configuration 2, 8, 8, 2. Yeah. So outermost shell, you can see that there are two electrons she has. I told her specifically that you can use different colors so that we will know. Okay, instead of using these clues, you can give. Okay, next one is oxygen. In the oxygen, you can see that outermost shell, how many electrons? What is the atomic number of oxygen? Can anybody say? What is the atomic number? Oxygen? Teachers?
8, ma'am. 8, ma'am.
8, very good, 8. So it is, how will you divide it? How will you divide it? K shell, how many electron?
2 and 6.
2 and 6. So here you can see that the child has 6. 1, 2, 3, 4, 5, 6. Now the 2 electrons from calcium is moving towards the oxygen. So here you see that the calcium, because the 2 electrons are lost, here you can see that the calcium has got a 2 positive charge. Can you see that? Yes. And oxygen has gained 2 negative charges. The 2 electrons are indicated using red balls here. You can see. So now using this project, the child has understood the concept very clearly. It has understood that when an electron is given, it will carry a positive charge. It will become a cation. When electron is gained, it will become a negative anion. And cation, anion together, it forms calcium oxide. Here she has also written the valency of the element. We have learned to write the formula. We use crisscross method. So she has written, what is it? Both are having 2, we'll reduce to the lowest number. So the formula of calcium oxide is CaO. And she has also given an extra information. Chemical name of the calcium oxide is quicklime. So you can see this is how you create interest in the students so that they are able to do the projects more easily. One more, 9th standard, I will show you. This is about structure of atoms. How electrons are arranged in each shell, the child has shown. Can you see it, Bam? Can you?
Yes, ma'am. Yes, ma'am.
Yes, yes. So here you can see that they have used magnesium as the element. Okay, the atomic number, she has written it as 12. Okay, and she has written the configuration also. In K shell, you will have 2 electrons. So she has indicated this is the K shell, 2 electrons are there. Then in L shell, it will have 8 electrons. You can see that she has stick 8 dots. And in M shell, it has got 2 electrons. So the valency is number of electron in the outermost shell. So she has also written the valency as 2. So when you give them like this integrated projects, you see that the children will understand the concepts better. And being girls or boys, whoever it is, they would like to do all these kind of works. They will have more interest to it and they will learn to do it in a better manner. So now I will share some of the 10th standard art integrated project. Here you can see, I don't know whether you can see, the child has done the structure of methanoic acid. Okay, HCOOH, you can see here. Here, this is H, she has used clay, the model of clay, and she has shown how methanoic acid is formed. Here you can see that between carbon and oxygen, there is a double bond. Can you see there are 2 sticks she
Yes,
has
ma'am.
told you. So when you have 2 sticks, they will understand it's a double bond. And here between hydrogen and carbon, there is a single bond. Can you see that? Yes,
Yes,
between carbon. So here you can see that the valency of oxygen is 2. So you have 2
One is to
sticks on
carbon,
the
one is to
either side
hydrogen.
of oxygen. You can see here, one with carbon, the other one with hydrogen. So all these informations and instructions, they understand when you give them to make a art integrated project. See, this one is again ethanol. Structure of ethanol, the child has done here. Here you can see first she has written the electron dot structure is very, very important. You know that we are having in the board exam, they are being asked to draw the structure, electron dot structure of compounds. Here she has drawn the electron dot structure. You can see that between carbon and carbon, she has got only 1 pair of electron. I don't know whether 1 minute, ma'am. I will try to click. 1 minute. I'll see whether I can make it bigger. Either.
We can
you
enlarge
see it
it.
better now, ma'am?
Yes, ma'am. Yes, yes.
Yes, okay. So here you can see that between carbon and carbon, only a pair of electron. So they will understand that a covalent bond, a single covalent is formed when there is only a pair of electron that is shared. You can teach them that. Okay, why the electrons are, why the element is involving itself in bond formation in order to achieve 8 electrons in the outermost shell. All that you can see here. Here 2 electrons, here 4 electrons, here 6 electrons, 8 electrons. So this carbon has achieved 8 electrons in the outermost shell by involving itself in the chemical reaction. You can tell them that. So all these things they will be able to learn and do it better. Here also you can see that here he has drawn the structural formula. You can see there. Single bond. This is also asked in the board examination. They're asking you the structural formula. They're asking you the electron dot structure. So when I told them to do any art integrated project using for any compound. So the child has done this. So I have just shared both 9th and 10th. So you can encourage the children to do art integrated project, which will be helping them to get marks in the subject enrichment activity. Any doubts, ma'am?
No, ma'am.
No,
Can I
ma'am.
proceed?
Yes, ma'am.
Okay, thank you. The next one, what we are going to see is a portfolio. This time he has stressed more about portfolio. 1 minute. Okay, portfolio becomes a very, very important aspect in this thing, because he is given marks for it. What is a portfolio? A portfolio is a useful collection of purposely chosen and depicted. Purposely chosen, you are selecting, you have to select a topic. Depiction of depicting a selection of performances that are collected over a thing and represents the learner's effect, progress, growth, and accomplishment in the key areas. So how to do a portfolio, we will see that. Okay, so what are the things you need for a portfolio? That's very important. So a portfolio is done by the students by collecting certain topic, by selecting a topic and collecting information about it, and she has to make a booklet. That is what it is. Okay, now we will see what are the steps involved in a portfolio. First of all, you should choose a topic. Now here you can see a book. Okay, I'll be sharing this book now. Okay, this is the portfolio done by our student of DAV. So you should select a topic. Okay, then you should ask the child to do a research. Of course, we would have taught them, but still they can also do some research to collect certain information. For example, if they are talking about a reaction, they can write the definition of the reaction. They can try to get an example, pictures for example, like that. Okay, so they have to look for the informations and take notes. Choose several points you want to make about your subject. Find or create a picture of your subject. Label the picture with informative points you want to make. Then you should proofread it. Okay, this we have to insist, because children are, so even in this year, you should see that the child has made an error in spite of telling. Okay, a small mistake. Of course, children are to make mistakes and we are there to correct them in a gentle way. Okay, use any visual tricks you want to make your project look cool. Okay, so these are the things which they should know when they do a portfolio. So now I will try to share a portfolio, PDF of portfolio. 1 minute. Can you see it? So this book, what the child has done, I have made it in the form of PDF because I do not know whether you will be able to see. When we were doing this picture, 1 or 2 pages are not taken. So I will read out those pages. Okay. Shall we see this portfolio, madam? Yes.
Yes, ma'am. Yes, ma'am.
Right. So first I told you it becomes very important that the child write what portfolio it is. It's a chemistry, right? So the next here you can see that the child's name is there. It is a student of 10C. Her name is Vanilla. I would like to say that because she has taken really good efforts. And I told her that I will be sharing it with the teachers. So she was very happy. So like this, small words of encouragement really make the children to do well. Is it not? Yes or no? First thing they have to do is to write the heading. Okay. Chemical reactions and equation. That is the name of the topic. You can see here, I have not taken the picture properly because last minute addition it was. Here you can see. Can you see it? Here. It will be actually like this. Chemical reactions and equations, right? Next. So she has given the heading. So this is the topic on which she has done her portfolio, right? Next one is index. She has to give her index. So instruct your students to write the index. What are the things? Index combination. She is going to talk about combination reaction. She is going to talk about decomposition reaction, displacement reaction, oxidation and reduction reaction, corrosion and rancidity. So these are the topics on which she has prepared a portfolio. So when I look at the index, I will clearly get an idea what she has done. Yes or no, right? We'll go to the next one. So first she has written combination reaction. So here she has given a definition. You can see there. Reaction in which 2 or more reactants combine to form a single product. So A is one reactant, B is one reactant. Both of them give you only one product, AB. So now she has given a general definition and she will give an example. What is the example she has given? Just see there. Magnesium is burnt in air, it forms magnesium oxide. So magnesium is one element, oxygen is another element. Both of them burn and they give you magnesium oxide, which is a single compound. So whenever they write like this, insist them to balance the equation. So I have told them, insist them to write in which state they are. Magnesium solid state, you can see here, yes or no. Oxygen gaseous state, magnesium oxide solid state, because these things, you know, they are expecting in board. And see, for this, she has stuck a picture. 1 minute, I'll show you. Collection of picture portfolio la essential. Yeah. Here you can see there. Magnesium ribbon. Okay, it is burning in oxygen. You have a beautiful white light you can see. After burning, you can see a white powder here. So she has stuck an example. So she has taken combination reaction. She has explained the definition of it. She has given you an example for it. And she has stuck a picture. Now we'll move on to the next one. Okay. Decomposition reaction. This is what I told you last minute. I will show you. Okay, I didn't take the picture properly. Here you can see the picture, decomposition reaction. I am showing it. Please see, ma'am. Okay, decomposition she has written. What is she saying here? A reaction in which one compound decomposes to give you A and B. Then she is talking about the different types of decomposition reaction. Thermal decomposition reaction. A reaction in which you are using heat energy to decompose. She has given example for it. Photolytic decomposition, a reaction in which we are using sunlight or light for decomposition. She has given example for it. Electrolytic decomposition, a reaction in which we are using electricity to decompose. So water on passing electricity decomposes to hydrogen and oxygen. So this picture I didn't take. So she has written about all these things. But I told her to give only one example. You can see that she has given the picture. I'm sorry for being like this. You can see here two compounds. That's very important. You see two colors she has given. You can, all this is only very important to know whether the child has understood it. One is a cation. It has a different color. You can see there. The other one is an anion. So it forms a compound here. Two elements are there. Two different elements. She has indicated that. Then you see here, they are splitted up. So if it is going to be calcium oxide, we can say that calcium will be green in color, oxygen will be blue in color, calcium plus oxygen like that. So decomposition reaction, AB gives A plus B. She has given example for it. 2CO gives 2C plus O2. And she has given how, when you are in decomposition reaction, how elements alone, it splits into elements, how it splits into compound also. Both she has given us an example. So the next one, what we are going to see is, okay, displacement reaction. You know that displacement reaction is of two types. Single displacement reaction, double displacement reaction. So in single displacement reaction, you see that the less active metal from a compound is removed by the more active metal. A is a more active metal, B is a less active metal. So more active metal displaces less active metal. Adukku example here she has given. We have taught them that the mnemonics. Mnemonics they have the order of the reactivity. They are using here. You can see that. The more active metal is iron. The less active metal is copper. So where the more active metal displaces less active metal. So she has explained it with an example. Double displacement reaction, exchange of ion is taking place. AB is a salt formed between a cation and anion. Sodium is a cation, sulfate is an anion. Here barium is a cation, chlorine is an anion. The exchange of ion is taking place. Sodium is reacting with chlorine. Barium is reacting with sulfate. So exchange, when you see exchange of ions take place, we call that as double displacement reaction. She has also given you a note that in some double displacement reaction, precipitate will be formed. So she is trying to give us all the informations there. So when you look at the portfolio, you will understand whether the child has really understood the concept, whether the child is really clear about what she wants to say. Unless you are very clear about the concept, you can't make a portfolio. Is it not? So this is a very fantastic way of making the child to understand the concept. You can give them the freedom of taking any topics. You don't restrict them, do only in this, do only in that. Whatever you are feeling comfortable, you do. And give them ideas. I would say that children are having so much of talent. You put Tamil சொல்லுவாங்களே கோடு போட்டா ரோடு போடும் அந்த மாதிரி they are very 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 good. They are very creative. They are very they have a lot of originality. They come out with fantastic and fabulous ideas. The next one is an example. For single displacement, you can see that she has shown the iron nail dissolved in copper sulfate. You know that the iron nail and copper sulfate, when you immerse, the iron nail gets, the color of the iron nail changes, the color of copper sulfate changes. Even the color change, you can see that she has shown in the picture. So this is a example for single displacement reaction. And this is an example for double displacement reaction, wherein exchange of ions are taking place between copper and sulfate and sodium and hydroxide. You see that exchange of ions have taken place, and she has given a picture of that also, right? The next one, what she wants to say is about redox reaction. Here also I didn't record the definition of it. I will just 1 minute. Here you can see that oxidation and reduction. She has explained what is oxidation and what is reduction and what is redox reaction. So here you can see a redox reaction. Here she is telling you that a reaction in which oxidation and reduction takes place simultaneously. Both loss of electron as well as gain of electrons takes place side by side. That is why it's called redox. Red means reduction, ox means oxidation. So if a chemical reaction, reduction and oxidation takes place side by side, it is called redox reaction. So she has explained it diagrammatically. Okay. Then here, just now we saw with figures. She has explained with bars and arrow marks. You can see that what is oxidation, what is reduction, which is a reducing agent, that which loses electron, all that she has shown. So this is regarding redox reaction. And finally, she has talked about corrosion. What is corrosion? So corrosion is a process in which the metal gets eaten up gradually by the action of air. How will you prevent corrosion? She has given painting, application of oil or grease, galvanization, electroplating. So in galvanization also, she has mentioned what kind of metals can be used. Zinc can be used over iron. Electroplating, she is recommended chrome plating will be better. So the child is trying to give you maximum information that is possible in a particular topic, yes or no, right? So the next one for corrosion, she has given example. Here you can see that she has taken iron. Iron is reacting with oxygen and water. The color change, rust is formed. So beautifully she has shown how the color of the screw, the iron nail changes. She has shown here. So next one is rancidity. You know that one of the important application of oxidation reaction is rancidity, that is spoilage of food. The food contained lot of acids and fats and oil, and these fats and oil are getting spoiled when they are kept in a long time due to the exposure of air. So how can you prevent rancidity? She's given you the options. That is, you can use antioxidants. You can pack them nicely using nitrogen gas, flush them with nitrogen gas, refrigeration, vacuum packing, airtight containers, storing it away from light. All these methods can be used for preventing rancidity. Okay, and finally, she has given, we have to give an example, yes or no? Yes, here you can see that how, because of rancidity, how the vegetable gets spoiled. She has shown by the picture. So this is the portfolio that is prepared by the child for her submission to 10th standard board exam. So practicals, we know that practical is a very, very important skill the child has to develop. And we for 10th standard, and 9th standard, the children are have to be taken to the lab, and we have to show them the what should I say? We have to show them, because you know that the practical plays a very, very important role in developing the knowledge. Practically, they gain the skill. Okay, they do and they learn. Learning by doing. That is called as experiential learning, is it not? We are learning now recently that we are learning about so many skills. So that is one of the main reasons why CBSE has introduced practical, so that they become familiar with all the basic things that they need to know. They will be able to identify the asset. They will be able to identify the basis. They will be able to do some experiments. They will identify what is a combination reaction, decomposition reaction, displacement reaction. All these things they will be able to know. So that is why. And not only that, it helps them to develop observation skill. So when a reaction is taking place, what are the changes? The child has to observe it. So all this is possible only because of the practicals. So in 10th standard, you know, for chemistry, we have the following practical sessions. One is pH paper. So we'll be given a pH paper. We will be given some samples. Based on the color, we have to identify whether the substance is an acid or a base or a salt. Next, I mean, acid or a base. Next, properties of acid and bases using blue orange. We will try to identify whether it's an acid or a base. Types of reaction, you know that. Combination reaction, decomposition reaction, displacement reactions and all, we will be showing them. We'll be showing them this iron nail and copper sulfate solution. We'll be showing them. We'll be showing exothermic, endothermic reactions. Heat is liberated, heat is absorbed, and all those things they will be seeing. Reactivity series, same way, putting zinc in copper sulfate solution. How the color of zinc changes into black color. How the color of copper sulfate changes. All this we will demonstrate and show. Similarly, this time I think he has included properties of acetic acid. Is it not? Yes, properties of acetic acid, cleaning capacity of soap in hard and soft water. All this has been included now. So we have to instruct them. We have to take them to the lab. We can demonstrate and show to them how to identify all these things. And we can tell them to write the record, because you know that record also deserves some marks in the so it's very, very important that they maintain the record neatly. They write the record properly. They use tabular columns. They write the equations properly, balanced equation, result is there, aim is there, material required is there, principle is there. All that the children should know. They should understand it, and they should also record it in a neat manner. So that is what is regarding the practicals. So I think we have discussed today about in detail about the important activities. So similarly, you can also tell them every day. What I do is we will try to give them a value-based concept. Okay, that's very, very, very important. So you can just give them some kind of paragraph, and you can ask them what is that they understand. For example, today I told you that in the leaf falls down because of the presence of abscisic acid. I told you. So that is something new. So every day you try to give them some new input. This will only create a my children will be waiting. I will every last 5 minutes they know that there is going to be something new that they are going to learn. For that 5 minutes, 35 minutes, they will be sitting quietly, they will be listening, they will be responding, because I will tell them when you are going to be good, okay, then only I will be discussing the topic today, otherwise no, like that. So they will be waiting for that 5 minutes. So this is what you have to instigate in the children. You have to tell them in the last 5 minutes, you should have something very creative, something very, what should I say, very interesting for the child. Maybe even a playway method. For example, here you can see that generally we play a game. 1 minute, I'll just take a chalk this. For 9th standard, can you see the board, ma'am? Yeah. We will play a game.
Yes, ma'am.
This game, you know, children will play with X's and tick. Is it not? In our science class, we play with cations and anions. So I will say today we will play. I will not tell them with what. Okay, I will tell them like today, let us play. I will play as a cation. You will play as an anion. Okay, cation with one positive charge. So now imagine that I am the teacher. So first I will write here Na plus. Now the child will write here Cl minus, anion negative. So now my turn. I will write here K plus. She will write here Br minus. Now if she, I will write here. What can I write? Can you tell me one cation with positive charge?
Lithium.
Huh? Lithium. Correct.
Lithium.
I plus. So now you see that I am the winner. You can ask them to play like this. It's a wonderful game. You don't have to tell them what they are going to play. You don't have to tell them what they are going to learn. You can call one student, try to make a compound out of it. Now they will make as many as possible. Li and Br join together, give you LiBr. Li and Cl join together, give you LiCl. Na and Cl join to give you NaCl. Na and Br join to give you NaBr. Is it not? K and Cl gives you KCl. K and Br give you KBr. Now playfully they have learned this many compounds. Yes or no?
Yes.
So this is one way of no. Only when they think they are learning, they get stressed. Okay, but now they don't think at all. They just play. When they play, they learn unknowingly. So this kind of instigation you can instill in them. You can give them like this. Some games, okay, or you can have a box. You can put some yellow color chits and blue color chits. Yellow will have all cations, blue will have, you can match them, write the compounds like that. Use playway methods to write the formulas, to write the valency, to identify the valencies. All these will help them to understand, okay, and do chemistry. They will start liking the subject.